Every day, we're amazed by the vastness of the universe and the mysteries it holds. Countless stars dot the cosmos, each one harboring unique secrets. And every day, new worlds are discovered around these stars, like tiny grains of sand on an infinite beach. But as we explore these new horizons, we can't forget about our own solar system. After all, it's the only known place where life flourishes. Our solar system is made up of 8 planets, dozens of moons, and millions of smaller celestial bodies. Many of them remain enigmas, even after years of observation. Today, I'm going to guide you on a fascinating journey through the most intriguing corners of our system. Ready to go? On November 21st, 2021, the Parker Solar Probe approached within just 4.65 million miles of the Sun, becoming the first to touch the solar corona, that insanely hot outer layer. But why do we go to such lengths to get so close to the Sun, a place where everything disintegrates? To understand, we need to learn more about our star. The Sun, a main sequence star, is about 4.6 billion years old and has a surface temperature of approximately 9,986 degrees Fahrenheit. That's more than 20 times hotter than an industrial oven. Plus, the Sun is massive, brighter and larger than 80% of the stars in our galaxy. Just to put it into perspective, if the Sun were the size of a basketball, Earth would be the size of a pea orbiting around it. What fascinates scientists is the Sun's complexity. In the core, thermonuclear reactions generate colossal energy that takes thousands of years to reach the surface, passing through the radiation zone. There, the energy is absorbed and re-emitted so many times that it can remain trapped for up to 170,000 years. Talk about stellar patience, right? Imagine a giant maze where, just as you think you're about to exit, you're redirected to another part of the labyrinth. That's the journey of energy inside the Sun. While the Sun heats the surrounding space with its visible radiation, the outer layers, like the corona, are incredibly hot, reaching millions of degrees Fahrenheit. But these layers contribute very little to the visible radiation we see. Why? This is one of the big questions the Parker Solar Probe is trying to answer. To do this, the probe was equipped with a highly advanced thermal shield, capable of withstanding temperatures that can reach 2,498 degrees Fahrenheit, almost the melting point of iron. But before Parker is finally consumed by the Sun, it will send back an incredible amount of data, helping humanity uncover more about the star that defines our lives. Leaving the Sun behind, let's head to Mercury, the closest planet. Did you know that Mercury is the smallest planet in the solar system? So small that some moons are larger. But despite its size, Mercury is surprisingly dense, with a massive metallic core that makes up about 57% of its volume. It's like taking a giant iron ball and covering it with a thin layer of rock. That's Mercury. Now, imagine a planet so close to the Sun that its surface reaches 800 degrees Fahrenheit during the day. But in its polar regions, the temperature can drop to an astonishing 315 degrees. On Mercury, the contrast is extreme. It's like being in a hot oven, but just a few steps away, you'd find yourself in a giant freezer. The Cretaceous-Paleogene extinction event was a turning point in Earth's history, paving the way for the Cenozoic era. 66 million years ago, the planet underwent drastic transformations, becoming a home for an impressive diversity of creatures. With the dinosaurs extinct, mammals quickly spread into the ecological niches left behind. Fascinating creatures like the gigantic Indricotherium, the fierce Andrewsarchus, and the Archaeocetes, ancestors of modern cetaceans, emerged. Some of these creatures vanished without a trace, while others evolved and adapted to the changes. 23 million years ago, the Neogene period began, marking a time of global cooling. Polar ice caps grew, sea levels dropped, and mountain ranges like the Alps and the Andes continued to rise. During this time, the Mediterranean Sea nearly dried up, turning into a salty desert. Back then, the planet was inhabited by bizarre creatures like the Gigantopithecus, a primate over 10 feet tall, and the Megalodon, the largest carnivorous shark ever to exist, creatures that lived in a wild and unforgiving world. About 5 million years ago, an earthquake opened a gap in the rocky barrier separating the Mediterranean from the Atlantic. A colossal flood, known as the Zanclean Deluge, refilled the Mediterranean in just 2 years. The power of this catastrophe was 40,000 times greater than Niagara Falls. During the Pliocene, which followed the Zanclean Deluge, the continents took the positions we recognize today. The climate was warmer, and our earliest ancestors began to explore the African savanna, facing challenges that would shape our evolution. But what led these ancient primates to leave the trees and explore the open plains? Around 3 million years ago, the Isthmus of Panama emerged, separating the Atlantic and Pacific Oceans, drastically altering air currents and global climate. This led to the planet cooling and the expansion of the African savannas. Our ancestors, like Ardipithecus and Sahelanthropus, were forced to adapt. The savanna was full of dangers, and walking upright allowed them to spot prey or predators from a distance. With their hands free, they could manipulate primitive tools, essential for hunting and defense. These changes led to the emergence of Australopithecus, who lived in Africa between 4.2 and 1.8 million years ago. Although they still looked like apes, they were on the path to becoming human. They lived in tribes, developing group hunting and defense skills, but faced a short and dangerous life, constantly threatened by predators like Dinophalus. As the climate continued to change, new species emerged. Homo habilis, the first representative of the human genus, appeared around 2.3 million years ago. With a more developed brain, they made rudimentary tools and had a more upright posture, paving the way for Homo erectus and, eventually, Homo sapiens. Over millennia, primitive tribes spread across the globe, exploring new territories. Meanwhile, the Pleistocene megafauna began to disappear. Mammoths, giant sloths, and saber-toothed tigers vanished, while humanity continued to adapt and evolve. 12,000 years ago, a new era began, the Holocene. The end of the last ice age brought a warmer, wetter climate, allowing our ancestors to establish agricultural communities in the fertile valleys of the Middle East and along the Nile. This transition marked the beginning of human civilization and the end of the Pleistocene. Our next stop is Mars, the red planet. Mars is about 1.5 times farther from the Sun than Earth, with temperatures ranging from 243 degrees Fahrenheit at the poles to 95 degrees Fahrenheit at the equator. Our starting point is Olympus Mons, the largest volcano in the solar system, standing 16 miles high, about 2.5 times the height of Mount Everest. Imagine a mountain that not only reaches, but surpasses the clouds, stretching almost into space. Descending from Olympus Mons, we explore the vast Tharsis region and reach Valles Marineris, a network of gigantic canyons. Mars holds many mysteries, like Jezero Crater, where the Perseverance rover and Ingenuity helicopter have been on a mission since 2021. It's believed that this crater once held a lake billions of years ago, making it one of the most promising places to find signs of ancient life on Mars. From Mars, we head to the asteroid belt, a mysterious and ever-changing region where more than 300,000 small celestial bodies have been cataloged to date. But what else awaits us? That's a story for the next part of our journey through the solar system. See you in the next video.